Welcome everybody. Today we're talking about solving similar triangles. Now you might notice that we have a different symbol being used for similar, but it looks kind of familiar. It's that squiggle that we see on top of congruency, but it's not congruent. We're talking about similar, which is going to have two specific properties. Now they tell us right now that triangle ABC is similar to triangle DEF. What it means to be similar is two things. First of all, we're going to have proportional sides. What that means is that the scale factor from AB to DE has to be the same scale factor from BC to EF and from AC to DF. Meaning, if I figure out that from A to B I multiply by 2 to get DE, I would have to multiply AC and BC both by 2 in order to get these, in order for the sides to be proportional. Algebraically, what that looks like is this. AB compared to DE has to be the same ratio as BC is to EF, which also has to be the same ratio of AC compared to DF. If all three of these ratios are the same, if they're all equivalent, then we have proportional sides. The other thing that has to be true to have similar triangles is that we have to have congruent corresponding angles. Now we have a valid statement, so we already know what angles are corresponding. Angle A and angle D correspond, so for these triangles to be similar, angle A and angle D would have to be congruent. Same idea with B and E, as well as C and F. As long as we have all three corresponding angles congruent and all three side lengths proportional, we have similar triangles. Now we're going to look at a couple of problems. The first set of problems, we can already see what would be considered to be corresponding angles and what would be corresponding sides. What we're hoping for is that we can make these sides proportional. So we're actually going to set up a proportion just like we saw up here using these side lengths. We want to compare one triangle length to its corresponding side, set it equal to the same triangle over its corresponding side, and then we're going to solve. So let's set that up. We're going to look at LJ, which has a length of 28, and we're comparing it to its corresponding side of RP, which has a length of 42. That is going to be set equal now to KJ, which we have as X, compared to its corresponding side of QP. Now, if I were to simplify both of these, I would find that these are both divisible by 14, which is going to leave me with 2 over 3. Simplification is something that you have to think a little bit about. If you need to keep on dividing by 2 until you get down to the simplest form, that's fine. I just recognize right away that this reduces to 2/3. What I'm going to do next, oops, I'm sorry, I should have wrote 33 here. My mistake, guys. Right, QP was 33. What I'm going to do now is cross multiply. I'm going to multiply 2 times 33, which is going to give me 66. That's going to be equal to 3 times x, which is 3x. My last step here is to divide by 3, which will give me a solution of 22. Now, if I was to look at 22 over 33 and reduce these both are divisible by 11. That gives me 2/3, which is equal to my other ratio. So we're correct with our answer 22. We even have the ability to check if we need to. This next problem doesn't look quite as friendly because we have triangles that are mixed together. Now let me give you guys a quick warning about a problem like this. We're going to be comparing the side length of this smaller triangle, and we're going to compare it to the entire length of the larger triangle. What commonly happens a lot of times is that people will compare only this small piece. We're not talking about just the small piece. We want to know the entire side length. So for right now, I'm going to color my smaller triangle with red so that we can see it clearly. And then I'm going to color my larger triangle with blue so that we know exactly what we're talking about. I want to compare my small triangle to my large triangle. Well, it tells me that I have 18 for this small piece and 6 for this other piece. So altogether, this entire length is going to be 24. Now, real quick, that 18 was only there so that I could figure out the entire length. I don't want it to confuse me any further, so I'm going to just kind of eliminate it from my problem. But as far as this side, well, they give me the entire length of the blue triangle as 12, and then they give me this piece as x. But I need this red triangle information. Well, that's easy enough to do. If the entire length is 12, and I don't want x, I would subtract that away. So I would be taking the length of 12 and subtracting x to get this missing piece. So BU, the red triangle piece that we want, is 12 minus x. Now we have enough information to set up our ratio. Again, by the way, this little piece, I'm going to get rid of it because I don't want it to confuse me. So I'm going to set up my ratio of the small red triangle side, which is 12 minus x. I'm going to compare it to its larger triangle side, the blue one, which has a length of 12. I'm going to set that equal, again, using my smaller triangle, the red one, which has a length of 6, and I'm comparing it to a full length of the blue, which is 24. Okay, so notice red triangle both times is on top, blue triangle both times shows up on bottom. So I have the right triangles in the correct places, and I have the correct corresponding sides being compared. If I can simplify, I'm going to. 6 and 24 reduce to 1 over 4. I need to cross multiply. 12 times 1, easy enough to do, gives me 12. 12x minus 4, well, I have to do some distribution. Okay, this is 4 times 12 minus x. I need to distribute my 4 both to the 12 and to the x. So that's going to give me 48 minus 4x. Now I have something that I can work with. I'm going to subtract 48 from both sides. That will leave me with negative 36 equals negative 4x. Nothing bad here because I can divide both sides by a negative 4. My negatives cancel each other out. 36 divided by 4, that's going to leave me with 9. Over here I'm left with x. So my solution here is x equals 9. I have another example for you to try on your own if you want to pause the video on your own so you can try it out, and you can press resume afterwards to see how you did. Alright, let's check out, see how you did. Again, I'm going to quickly just kind of color in these triangles. Here's my smaller triangle in red. I'm going to be comparing the small side of the red to the entire length of blue, which I'm going to color in right now. Okay, so we can see that we have overlapping triangles. Well, we had mentioned that we need to know the length of the red. Right now they give us the length of the red. They give us the length as x. So we don't need to do anything special to change that. Just keep it as x. They also give us a length right here of 6, which I think I might use. I could use the 9. Nothing wrong with that. But I'm going to use this 6. Just a personal preference. They also give me the entire length of the blue side as 22 and the entire length of this blue side as 12. So I have all the numbers that I need in order to set up my ratio. So I'm going to compare my red to its blue, so x over 22, and again I'm going to compare the red to blue. I'm going to simplify if I can. That simplifies to 1/2, and then I just quickly cross multiply. X times 2 is going to give me 2x. 22 times 1 gives me just plain old 22. Divide by 2 on both sides. X equals 11. So I have found the missing side length. Hopefully you got that one right. Here's another example. It's pretty much the same thing that we were doing. However, this time we have an equation. Well, is that going to alter what we're going to do? No, because we're still thinking about the fact that we have proportional sides. We just need to set up the correct proportion. And lucky for us, they tell us right in the instructions what sides and what angles correspond to make our proportions. So what I should notice is that on one of my triangles, side AB, which is the first 2 letters, it has to correspond with the first 2 letters of my other triangle, which happens to be FE. So I want to make sure when I set my proportion up that I use those 2 sides. The next side that they give me is AC. AC are my first and last letters of my valid statement. That means I want to be using FD, which happens to be 24. So when I write my ratio out, I'm going to use 5x plus 11 compared to 18 as 88 compares to 24. Now I have the proper ratios set up. Let's reduce if we can. These both look to be divisible by 8, so that's going to give me 11 over 3. And now my multiplication should come out a little bit easier. Let's see, we have 11 times 18. That's going to give me 198 on one side. And here I have 3 times 5x plus 11. Well, 3 times 5x gives me 15x. 3 times 11 gives me 33. I'm going to subtract the 33 from both sides. That's going to give me, let's see, 165 equals 15x. If I divide by 15 on both sides, well, that looks like 11. So the missing value of this problem is 11. Okay, so again, we didn't do anything different. We set up a ratio just like we did in all the other problems. So here's an example for you to try. Remember, you have a valid statement that you can use to help you set up your proportion. Take a second, try this one on your own, pause it, and when you're finished, resume to check to see how you did. Alright, let's check it out. Hopefully you noticed that WU would have to match up with RT. So here we go. Here's WU and RT. That's my first ratio, which is going to leave VU matching up with SR. So 77 to 21. Key to the problem, if you don't have this ratio set up, you're not going to get the problem right necessarily. So let's reduce. 7 and 21 reduces to 11 over 3. I'm going to have to do my cross multiplication. Alright, let's do a little bit of multiplication on the side over here. I have 330 is equal to 33x plus 33. I'm I'm going to subtract 33 from both sides. Well, let's see, I got to do a little bit of borrowing. 297 equals 33x. And if I divide by 33 on both sides, what is 297 divided by 33? Hopefully you guys have a calculator present if you need to do this on calculator. I came up with 9 as a solution. So how did you do? Hopefully you did okay. The important thing to keep in mind is setting up the correct ratios. Use the valid statements when you can to set them up. As long as you have the correct ratios, they will set up the proportion properly. You'll have your answers with just a little bit of multiplication in algebra. Any questions you have, post them either on the website or bring them in to me on class. I'll see you soon.